11 of Advent of Code 2025 with Dmitry, and let's start. So today we are in the reactor. Okay, that's a lot of radiation, but never mind. Okay, so I have already read the task, and basically you have a graph, a directed graph, that says that from this node you can go to this node, from this to this, and so on and so on. You start at U, at the node called U, and you have to come to the node called out. And then they basically ask how many paths are there from U to out. That's basically it. My intuition is that if you want to find the number of paths in a directed graph, you can do it recursively. Basically, you reverse the edges in this graph, and then you start with the node that you want to come into and assign it one path, because if you're already that node, you have one definite path to that node. Basically, it cannot be zero, because that would mean that there are no paths, and it does not make much sense to assign more than one path from the node to itself. You look at its neighbors. So initially they were its predecessors in the graph, and you propagate that one to that nodes. There are no multi-edges in that graph, so you can only come to a node only in one way. So basically one is propagated, and then you repeat that recursively until you reach the node that you want to start the path from. And when you have edges that come into one node in the reverse order, you have to sum the number of paths over the nodes that were successors for that node before reversing the path. So yeah, it sounds complicated, but yeah, let me find an image. Finding the number of paths between nodes in a DAG. And let me just illustrate that. So for example, this one. You want to come from this node to this one, and basically this is your destination node. Imagine that you reverse the edges, and you can come from this node by one pass, from this node to this node by one pass. You propagate 1, 1, 1. And then you also have to update this node. Let's just read about that. Memorized recursion. Logical sort. Okay. Then scan the vertices from the target backwards to the source, which keep a count. When you get to the source, the value. Oh yeah, so that's topological sort. Okay. Okay. Topological sort can be done by repeated DFS, if I remember correctly. I did that recently, but I need to have a refresher about this. So, as usually, you have unvisited, discovered, and processed nodes, as it is usually called black, gray, and white nodes. And then you do DFS, and then, so basically this is just the traversal in which you also add a node to some list. And when the traversal is done, the list contains topological sorting of the nodes. It does not seem conceptually complicated, but there is some work to do. Yeah. So let's have day 11. Let's grab the example. Let's grab the input. Day 11. Okay. Let's do cargo new. Of code 11. Let's run that. Maybe I could even solve it in graph X very quickly, but that almost feels like cheating. But why not? Actually, why not? So, Python 3.14. Sometimes I just don't want to spend too much time on this. If it's conceptually simple, then why should I care about some complications? I can always rewrite it in Rust if I want to. And I can also try graph libraries for Rust as well. Yeah. Yes. Let's move it out here. What I can do? I can do pip install what was networkx. Yeah. In case you don't know, networkx is a very featureful and very well-known graph library for Python. I recommend taking a look at it if you want to work with graphs. So now, should I do it in Z? Maybe. Okay. Okay, so I have this solve by. Name is main. Let's say that path with text. Path is example txt with text. Example input is path input txt with text. Let's input it. By the way, I like this. This is compared to VS Code. VS Code just tries to auto-import everything, and that is annoying because it's very easy to import not the thing you want. But here it just points out that I don't know what's this, and then you just do a code action and import and select what you actually want. And I like this pull model. It does not push on you all of these imports that you don't want. Yeah, I like it. Okay, let's say that solve one of example should be should be 5 different paths. Yeah, why not? And yeah, well, it's almost feel like cheating because actually networkx might even have a helper for getting the number of paths in a directed graph. And that would be real cheating. Why not? Let's try to do it that way. Okay. What do you not like? Ah, yes, it already type checks. Wow. Okay. I'm not against this. Okay. Now we have to parse it and construct the graph. So let's say that G is networkx. Put networkx as, I don't know, nx. What is the usual shortcut? So nx. Not the dgraph. Yeah, it looks like I will have to read the docs pretty often. Graphs, dgraphs, and multigraphs. Okay. Documentation. Okay. Install tutorials. Reference. Yes, I want reference. Basics. Graphs. Nodes and edges. Add edge. Dgraph is a directed graph. That's what I want, yeah. Dgraph for line in the part before and the part after of a line split by this. Yeah. Now, if I take a look at example.txt, input.txt, what I can do. So let's add edge from this one add edges from add all the edges in a bunch to add. Yeah, that's how I can add multiple edges. What I can do, edges from to split successor nodes out neighbors. And yes, then I add node S1 from node to neighbor for neighbor in neighbors. No. Yeah. And then G. So what can I do? Attribute predecessor, successor, edge, attribute, graph. Whatever. Let's take a look at functions. Degree is directed. What am I looking for? Path. Is path weight. Maybe this. Not interested in. Okay, I just need topological sorting then. Maybe I'm missing a helper that is already there, but let's just do a topological sort and next topological sort of a graph. Yeah, well, that works for me. Next topological sort of the graph, and let's make it a list. Let's take a look. this exception to do. Yeah, so the topological sorting is AA, U, BB, HH, because it relies on CC, BB, CC, yeah, BB must come before DD and EE. Yeah, that looks good. And then what you basically do, you number of paths. So yeah, so basically, yeah, my intuition was correct. You have to go to the nodes in the backwards and start with the number of paths 1, and then you add so basically was it's a 0 for in range no, just in nodes. Okay, now let's mark the last one. Maybe let's just have a map and pass. It's an empty map, which is a dictionary from str from node to int. Good. And pass out should be 1. And now let's propagate backwards for node in nodes reversed. Nodes. Yeah, now we know the nodes in the backwards topological order for let's call it U maybe for V in U graph get edges adjacency iterator over node adjacency. Okay, cached property node as graph into 3 2 color blue sets. I see. Okay, yeah, in adjacency U. Can I do it like this? Equal, U is equal. Yeah, perfect. So example txt. So where is out? Only here, here, and here, and it goes back to GG. Yes, it goes back to F. Yes, it goes back to EEE. Interesting. How is this possible? Interesting. Okay, should I care about this? Another nice thing about this is nodes cached property. If I just take a name and I just assign and pass in there to 1, then I should be able to use it here. And basically that would be actually graph nodes u and pass, and in that case and pass updated by nodes u, nodes v, and pass, and in the end pass is equal to let's take this, put it here, and let's see, and then let's just put it back into u and pass. Okay, and in the end what I return is graph nodes u and pass, and that should solve it, I guess. No? Key error and pass. Okay. Data. So how can I use it? How do I put additional? Yes, that's how you do it. What's wrong? Pass is 0. No. Why? Because this now needs to have parentheses. And no, that didn't fix it. Key error and pass from line 21. It still doesn't like this attribute. Can I do get and pass 0 here? I can. Now I... Oh, yeah. Yeah, that's how you do it. And here you also get n pass or 0. And yeah, I like this form more actually. And at you have 5 pass. Okay. Will that solve everything? Print solve 1 for input. I think so. What is this crap? Maybe it does have this number of pass. I wouldn't be surprised. But in that case, I'm also wondering, what is it like? Does it fit in U64? Yeah. So that should be fine. Yeah, nice. Okay. Continue to part 2. Now, I'm not sure that networkx will be sufficient by itself. Maybe I will have to re-implement some algorithms. But let's wait. Aha, okay. SVR, and the path must contain GAC and FFT. Okay. And wait, did the example changed? Did the example change? Yeah, it has changed. Okay. I cannot say I like this, but whatever. So only two paths. Okay. So the initial node is SVR, server rack, to out. The end node is out, and the every path should include FFT and DAC. Okay. And DAC might come before FFT. That's fine. Only two paths, both DAC and FFT. So basically, is my intuition correct that you find the number of paths from SVR to FFT, then you find the number of paths from FFT to DAC, or the other way, and then the number of paths from DAC or FFT to out. And then every path from here can be combined with every path from here, and every path from here. So there is only one path here. There is only one path here, and there are two paths here. And when multiplied, that produces two paths. Okay, fine. I think I can do it. Let's go. devsolve2 lve2. As string produces an integer, and for now exception todu something. Okay, now assert solve2 example2 is equal to 2, where example2 is like this. Now print solve2 of input. It hasn't changed. Nice. Pray I won't change any inputs any further. Yeah. So now it should yeah, it should blow up here. Good. Should I just copy it? Next graph. Do you not like? topology. And now that looks fine. Parse s. It still fails in I cannot click to the position anymore, but yeah, I fell in it to do, so that's good. Okay, solve 2. So again, I pass the graph. I get the list of nodes, the ordered list of nodes, topological sort of the graph, and now let's solve. So who comes first? FFT or DAC? Next question, how many paths from SVR to the first stop? How many paths between the first and the second stop? Many paths from the second stop to out. Yep, and then the result will be the product of these 3. So the question is, who comes first, FFT or DAC? For n in nodes, if n is equal to FFT, then first second is FFT DAC. Break. Leave. Yeah. You can actually do this. Match n case FFT. Break. Case DAC. First, second is DAC FFT. Break. Else? Can you do? No, I cannot do else here. Case whatever. Can you do this? Actually, I don't want to. Okay. Print. Yeah, let's say this. Print. Oh, actually, else. Raise. Exception. Again. Exception. So not found DAC or FFT. In the other case, sysstdr print first, second. Does that answer my question? Without, yeah, you're right. So first is FFT, second is DAC. Good. Now, it feels like this requires a helper. And pass. In the graph, start and int. So, what does that helper look like? Yeah, I think it was a good idea to have an external array, but in this case it's just a dictionary from a node to an integer. Okay, now it's also a good idea to have topological sort as well. Topological sort of G, and let's make it a list. Now let's find index. Let's find the index of the end. Let's find the index of the beginning. So that will be 1, that will be 0. What's index of the start? Now, for I in range from I plus 1 to, wait, no, like this, I guess, minus 1. Is it how you do it? Print node is nodes I just want to verify that it does what I think it does. What I think it does. And then exception to do. Ah, yes, count path. It doesn't work yet. What did I press? Ah. Go away. Yeah. I'm not interested in this anymore, but I'm pretty much interested in this. So, how many paths from SVR to the first stop? N0 is count paths from SVR to the first. And one is count paths from first to second. And it's actually nice how the code becomes the pseudocode naturally. And from the second to out to out, yes. And now the result should be n0 by n1 by n2. That's one. Yes, the graph here, the graph here, and the graph here. Let's see. So, first FFT, second DAC. We try to go from FFT to PV to AI to SVR. And we reached it, and after that we crashed. Yeah, that sounds good. Now, what do I do? Now I repeat the npass thing. So and pass. And paths, the last one is 1. Then I visit a node and for and I say that v is yeah, nodes I. Actually, I can do it like this. V is nodes I, and what I can do now? Pass V V in path nodes at V. Adjacency, no, adjacency of U. And so what is this? Is this the name? I think so, yes. Pass equal and pass of V of V, yes. And then let's put it back and pass and pass of V should be NP. What's on now? Ah, yes, pass of U. Wow. So technically V is in scope here, but this is not the intent. And what was the exact error here? Possibly unbound. Yes. That is interesting, yeah. And then I return what? And pass from the start, right? And pass from the start. Let's try to see. Ah, yes. Yeah. Possibly there is nothing in there at that point. Yes, and possibly there is nothing in here at this point. Oh. So you just checked this and everything else is fine. Yeah. Okay, let's solve the input. Come on. Let's try that. Let's try that anyway. And debug later. Does this number even make sense? Is it U64? Oh, it is. Yeah, it should be fine. Yay!